Welcome, everyone. Today we're going to be discussing percents and compound interest problems, both sort of the theory behind them, some of the differences and wrinkles that can exist, and also we're going to look at a series of problems. We'll get to as many problems as we possibly can today. You know that one of the drills is to subscribe and like these. That helps people find them. That helps people prepare. That also gets you updates and notifications on various other upcoming GMAT Club events. So, diving into percents and compound interest ideas. First, what we're doing today, we're just going to look at some basics. We're going to make sure that we have some knowledge of the mechanics of percents and some of the different terminology that will exist. And then we're going to look at interest problems as what I call progression problems. It's this idea of there is some original and then a sequence or series of changes. You progress from one state to the next, to the next, to the next. If any of you watched my presentation on standard deviation, in that presentation, there was a lot of animations, not a lot of pen on screen work, because the entire theme in that previous presentation was that you don't want to do pen to paper. You want to just sort of look at it and use theory or use logic to figure out what's happening in the problem. Today is the opposite. Not a lot of animations today, a lot of stylus on the screen, a lot of stuff you're going to be seeing like handwritten on the screen is my intent. Because part of what I want to do today is talk about how do we organize our work pen to paper to get us to a solution as efficiently as possible. Some percentage basics. First things first, definition. This is my definition. This may not be a technical definition, but it is one that works for me. It is something out of 100. Any percentage can, at its core, be translated as thing over 100 and then go to work. An important recognition is that a percentage is not a number. This exists as an opportunity for us, but also a potential trap. Since a percentage is not a number, it's very common for us to see an opportunity to choose our own numbers and then apply the percentage mechanics to the small, simple numbers that we choose. That is the opportunity. As for the trap that can exist, a percentage always operates on some base number. And if you try to apply a percentage to a different base number than the one they intended, you will get the question wrong. And that is the kind of game that they will play. As you see here, 20% isn't a 20. It is 21 over 100. So you have the fraction expression or decimal expression. As I mentioned a moment ago, make sure you apply the percentage to the correct base. I have this written as percent of versus percent change as though they are different. They're really not. It's really the same thing. It's just a difference in the number of steps. But that difference in the number of steps can change how we want to express our thoughts on paper as we see these different styles of language concerns around percentage ideas. A percentage of a number. How much of that base number do you need? You usually just apply it directly. 20% of 50, you take your percentage, 20 over 100, apply it to the 50 by multiplication, and you will get 10. Ta-da's, you're happy. A percentage increase or decrease, you've got to take more steps. You take your original, you take your piece of the original, and then you apply that piece to the original again, either adding it to the original or subtracting it to the original. So as you see here, 20% more than 50, you take your 20% of the 50, and then you would take a second step and add that back to the original 50. Percent of versus percent change, to some extent, you can translate them each to the other. You can translate a percent change as a percent of, if you wish. But if you are ever unsure about that, a core fallback can always be percent over 100 get the size piece, and then just take that piece and do with it what you were told. Again, if anybody else is in the chat, please do say hello. Please do let me know where you're joining us from and what time it is. Just love to hear that kind of thing. Percentage of, usually express it as a fraction or decimal and multiply base number. Percent change, if you know the percentage, you usually go ahead and express it as a fraction or decimal, and then you operate on the idea that every change is a change from that one base entity. So you take your fraction or decimal expression, add or subtract that from 1, either literally the digit 1, or possibly a fraction, for example, maybe 4/4. And then you can say that is your multiplication by the base number. Welcome, Tanya. Late night in India, but so glad that you can be joining us. Example here, 20% more than 50. You take your percentage piece, 20/100. You take your one base number. You collate those together. And welcome, Samprova. You collect that common denominator. You get 120/100. And now you have a 1.2 times 50 or over 6/5 times 50. Interest problems are merely applied percentage mechanics. And the wrinkle here is whether we have simple interest versus compound interest. Simple interest, they use the term simple for a reason. It is static. You take your initial interest calculation and you stack that interest to each period of accumulation. Compound interest, a famous quote attributed to Ben Franklin. I don't know if he ever actually said it. There is no force in the universe more powerful than compound interest. Compound interest gets recalculated every single time. Compound interest expands and works larger changes than simple interest would. Another common wrinkle with compound interest is that you'll often see it subdivided based on the number of interest payments within an amount of time. As an example here, 8% annual interest compounded twice in 1 year. You don't compound the 8% 2 times. It is an 8% annual effect, roughly. What you do is you do 2 4% interest accruals. If your 8% were compounded quarterly, you would do 4 2% interest accruals. In my experience, pretty much everyone finds compound interest more challenging. And it is more challenging because you are having to track more moving pieces. So be aware that if you are faced with a compound interest problem on the GMAT, you quite likely in for some more steps, some more mechanics, quite likely a more time-consuming problem than a simple interest problem or many other percentage problems. So, talking about pen to paper work here. Because interest problems deal with change over time, I like to do a progression. 8% annual interest compounded twice in 1 year. So my first question, and I would like to see responses in the chat. If this is compounded 2 times, why do I have 3 dashes? Why do I have 3 dashes for 2 compoundings? Why the extra dash? Please respond in the chat. And keep in mind, whenever I pose a question, I don't know is always an acceptable answer to any question I ask. The compounding is in the blanks, not the dashes. Devanshi, do you mean by that like I have sort of like this in-between space? Is that what you meant? And the compounding exists in those in-between spaces? Yes. So if the compounding exists in the blanks, but not on the dashes, we can acknowledge that that exists, and I can label what my compounding would be. If it is 8% interest compounded twice, 8% annual compounded twice in 1 year, this would be an increase of 4% each time. Oh, Arshdeep, no worries. And Tanya, thank you. Thank you for giving me the I don't know. Perfect. So, Arshdeep, what is the value of what we're solving for? We're not doing an exact problem yet. That's going to come in just a moment, actually. We are about to see an actual problem. This is more just how do I organize my thoughts on paper when I'm faced with an interest problem, when I'm faced with a progression. I have two compoundings. Those exist in the intervals. Those exist between the dashes. So as I move from dash to dash to dash, I will compound this interest 4% each time. Just a quick check on mechanics. If I want to increase something by 4%, what will I multiply by? Like I'll write parentheses for multiplication, multiplied by what each time? How do I concisely express using mathematical notation the idea of a 4% increase multiplied by 1.04? Again, coming back to the idea of a percentage change is your percentage either applied up or down from your one base entity. So here, the next step is, what are my dashes? I'm intrigued by Arshdeep's comment. The 100 times 4, and then 140 times 4, and then 560 times 4. It looks like you might be applying the percentage as though it was 40% interest instead of 4%. But maybe I'm misinterpreting your comment. Ah, yes. So if we take the starting value to be 100, we can do that. For the moment, I'm just going to say we have our starting value to be x, which, by the way, Arshdeep just said starting value. Tanya, this is why I have a third blank. Or I should say, this is why I have an extra blank. When I have a progression problem, always track your original. ORIG period, my abbreviation for original. And I do something like original, and then maybe like first period, and then second period, something like that. And so I build progression problems, track my original or now, and then progress forwards or backwards as desired. So if I start here, if I have an x, multiply that x by 1.04, and multiply that x by 1.04 again, and notice that I will now have 1.04 squared. Oh goodness, I forgot that PowerPoint sometimes freaks out when I try and annotate on the screen. So what we see here is now yet one more wrinkle to compound interest style problems. It can be the case that you also have to deal with exponent mechanics in these problems. Now, again, that can be a challenge, but it can also be a gift. Oh, yes. Again, sorry. Let's step back for a second. All this stuff is being recorded. This will be accessible on YouTube for future reference. If you subscribe, if you like, particularly if you subscribe, you will know exactly how to find this video. And if you subscribe, you can find actually all of Manhattan Prep's GMAT prep videos. I did one 2-3 weeks ago on standard deviation ideas. I've done 2 in the last year on critical reasoning challenges on the GMAT. One in particular was critical reasoning challenges when you have to deal with critical reasoning style concepts in the data insights section of the test. That was a particularly interesting video to prepare for because those are problems that I find very intriguingly challenged. Yeah, this video will be on YouTube for future reference. All of Manhattan Prep's GMAT Club seminars are available on YouTube. I don't know the exact turnaround time for when it's available. At the recording will be available on YouTube, but it will be there. Tanya, 8% interest compounded twice in 1 year. You take that 8%, you divide this into 2 4% applications. Again, a weird wrinkle of compound interest. Your annual interest, if it gets compounded multiple times in a year, you actually split it up into pieces and you do even applications to get the total of a supposed total of 8% at the end of this. Tanya, let me know if I have not interpreted your question correctly. If you had a different question intended by the 1.04 question mark comment. What I was saying just a moment ago, you will see exponent wrinkles in some compound interest problems. That can be a challenge, but it can also be a gift. Remember that the quantitative section of the GMAT, it's all multiple choice. And so you can use your knowledge of what exponent is required, what power would be required. And when you know what power would be required, that can actually allow you to start making decisions in the answer choices, because it's quite common that some of your answer choices would not have the correct exponent. For example, if this is a GMAT question and I have answer choices that look like, again, just making this up, but some answer choices might be 1.04 with other stuff around it. Some might be, you might have 2 that have 1.04 squared with some x's. You might have one like 1.04 squared with like an x squared. Maybe you could just play games with this. 1.04 cubed, and then 1.04 to the 4th. Just by our knowledge of how compound interest scales and knowing that with 2 compoundings, you're going to get to a second power relationship, you already know that only choices B and C could be possible. And so you can do a lot of good work that way. I'm going to hold here for a moment. I want to see if there are any questions that come into the chat, because in just a few moments, I've got a progression of, I've got 4, we'll see how many we get to, problems where we can test ourselves on these mechanics and on this theory. But first, I'm just going to hold for 1 minute. Let me see if there are any questions. Anahila, I'd be happy. Oh, yeah, you're correct. This would be B, yeah. The x doesn't get squared, only the interesting would. Sorry, forgot to finalize the circle answer here because this is not a real question. In the meantime, it looks like we're getting ready to see the next question. Anil, perhaps if we have time, I'll take a look at that question some more. Since I don't know the exact format of it, I don't know whether it was 2-part, like I don't know whether it's multiple choice. We may hold off on the full discussion of the specifics of that problem. But if we have time, maybe we'll discuss a little bit. Actually, sometimes there are a few questions where we put the knowledge for both SI and CI to get a solution, while solving sometimes get confused as to which one to use when. Okay. So Archdeep, the difference here between simple interest and compound interest is whether you do the same effect in each period of time. Do you apply the same percentage change in each period of time, or is it one application and then you just add on the result each time? Really, mathematically, the difference between simple interest and compound interest is the difference between addition and multiplication. Simple interest, you find out your interest, and then you just add that same interest every single time. So, for example, if you had $100 with 4% simple interest, you would add $4 every single time, plus 4, plus 4, plus 4, plus 4. If it's compound interest, if you have a new interest applied to each new result, then it's times 1.04 times 1.04 times 1.04. As for knowing to which one to use when, pausing to think for a moment. So that will depend on the story. For example, if you have a story about, let's say that there is a child who their height grows at a constant number of inches or a constant number of centimeters every month. That is simple interest. You add the same number of centimeter growth every single month because the growth amount doesn't change. However, if you have something like an animal population in a wildlife refuge, and this animal population increases by a factor of 20% every year, that would be compound interest, because there you are applying a multiplication factor to every single change. Each time it's times 1.5 times 1.5 times 1.5. And the trick is always going to be, because many questions, in fact, we'll see one today where it is a compound interest problem that is never described as compound interest. That term is never used. But the idea is you recognize that it is a multiplication in each interval. If it's a multiplication in each interval, if it's a multiplication change, you're using compound interest ideas. If it is an addition change, if it is the same number that changes, the same number of change each year, then that is simple interest. I am a little bit hamstrung here because I cannot bring up official problems because of copyright issues. But if you have a copy of the Manhattan Prep official guide by content area list, we list out a list of translations problems in that. Inside translations problems, you will see some compound interest versus simple interest ideas. And certainly Archie, yeah, we'll do that too. Other questions? Thank you all, by the way, for being so active in the chat. That makes things much more of a joy for me to work with here. All right. Everybody take 2 minutes. Give this question a try. As you get answer choices, I would like to see responses in the chat. Thank you, Frecius. I will say that we're coming up on the 2.5 minute mark. We just passed the 2.5 minute mark. So if you were taking the GMAT on default timing, you would want to be definitely finished with this problem by now. And if not, you'd want to make a guess. What I'd like to ask, and respond as concisely as you can in the chat, how do we know that X cannot be 25, 50, or 80? And how do we know that Y cannot be 125, 160, or 250? I'd love to see responses to that in the chat if you have them. The price is raised. So the price is raised. So why do we not say, well, it's raised, so it's a 25% increase? Your X% is a percentage of the original price. 100% of a price is no change. It's only if you exceed 100% of the price do we actually get an increase. So X has to be higher. The total revenue was the same for both months. So if we increased our price, but our revenue stayed the same, that means that our sales had to decrease to match that thing. So my Y has to be less than. Now, as for setting up our work here, we have our price per unit. We have our number sold, and we have our revenue. We have an original, and then we have a new. And we can set up a chart and run it through this way if we wish. Or we can recognize that if I start working with X and I go with a price per unit change of 125 over 100, which is the same thing as 5 over 4, just testing out that first number choice there. In order to get to the original revenue, I have to counteract that 5 over 4 increase with a 4/5 of that new number. And so we can see that 5/4 and 4/5, when I multiply those two together, you would counteract and you get back to the same value. So this is 100% of something, 125% of something, and 80% of the same. Purpose of this question, merely to just try and catch the language, to recognize that even though they're saying they raised the price, if it's a percentage of the original, your percentage of the original has to be larger than 100 to actually reflect an increase. You could also have very readily just chosen some numbers here and applied these percentages to the numbers as well. All right. Let's try this one next. Again, everyone take a few moments. Let me know an answer choice if you have one. Starting to get some answers in here. In terms of how we might organize our thoughts on paper here, I have some starting point. The starting point is 200. I have my x, whatever that may be, and I have comparing x against 200, but also comparing x against some other number, which is 50% of 500. 50% of 500, the same as 1/2 of 500, which is the same as 250. Now the trap here is in this. X is 150% greater than 200. So we take 200, we do 150%, and voila, we have 200 times 3/2. So we have 300. And you think, all right, X is greater than 100. What's the problem? If this is what I'm trying, where have I gone wrong? I'm just waiting to see if anyone can describe this error in the chat. I did a percent of, I did not do a percentage change. What I have to do is I have to do a 200 plus that 150% sized piece of the 200. Again, just simplifying here. Very common to do a factoring out common term approach in these types of percent change ideas. And when I do that, I'll get 5/2. So here I am multiplying by 5/2, not by 3/2, to get 500. And if I want this percent change right here, going from 250 to 500, well, my percent change can be expressed in many different ways, but if you have the actual numbers, you can express it as the difference over the original. My difference between those two terms is 250. Here, my original, I was moving from 250 to 500. So that 250 is my original, which means this is a 100% change. Just going to hold here. Any questions, comments, or concerns? All right. Thank you, John Fresco. Oh, John Fresco, I think I recognize that name. Were you, or I should say, I think I recognize your icon, the American, I think that's a photo of the Michael Scott from the American version of the Office television show. I think I recognize your photo there. Were you in a previous one of my seminars? John Francesco, I apologize for mispronouncing you a second ago. In the meantime, let's try this one next. Everybody take a few moments. Give this one a try. Yep, that's what I thought it was. All right, getting quite a few answers in. This one, a very classical percent change phrasing. Again, track my steps here. I have an original, and then I have sort of two intervals of change. My original is 150. I will increase that by 60%, and then I'll decrease it by Y%, and my result is 192. Increase something by 60% is the same as multiplying it by 1.6, or by, let's see, 16 over 10 by 8 over 5. And when I do that multiplication, I will get 240. Again, 150 times 8 over 5. 5 will go into 150 30 times. So I'll get 240 there. Glad we got you to stay up here for a little bit longer, Vignesh. How do I get this percent decrease? Again, there are various ways we can go about this, but one of the more common is to say once you actually have concrete numbers to work with, you can say percent change is always going to be difference over original. Do markup questions and percentages show up as a relevant part of GMAT focus? Very, very much so. This one is a little bit simpler than I would commonly expect on GMAT focus, but the principle is very much there. My intent is to close with a question today, which would be very, very similar to what you would see on the GMAT focus. Or I should say GMAT, because GMAT wants to drop the focus part and they just want to return to the trade name GMAT. The difference here is 48. Now I'm moving from the 240, so my original is my 240, and 24 can go into both of those. And so I'll end up with 2/10, which is a 20% change. Yeah, you will absolutely see markup questions on this. Arshdeep, in fact, I cannot quote the problems, and in fact, I can't look them up right now either while I'm in the middle of this presentation because I don't have that bandwidth on my screen. But Arshdeep, do you have a copy of the 2024 official guide? In fact, just everybody. I'd love to see responses in the chat. Do we all have, do we have copies of the 2024 official guide from GMAT? The official guide to the GMAT. If you do, and you look in the quantitative chapter, and I believe it's in the last 5, it might be in the last 10. Inside the last 5, maybe the last 10, there is definitely one question, which is a disguised simple interest problem. It references like a constant amount of growth, not a constant percentage growth or a constant multiplication of growth, but literal a constant amount, like a child who grows by the same number of centimeters every month. So you've got a disguised simple interest problem in there. Also in there, you've actually got a delightfully sneaky little percent markup question as well. So you will see these types of questions at high levels on the GMAT, definitely. Everybody take a few moments. Try this one. This will be the next to last problem for today. While all of y'all were attempting this problem, I did go ahead and look at my copy of the official guide. And it is inside the last 5 questions of the quantitative chapter. Let me just double check that to make sure. 1, 2, 3, 4, 5. Excuse me. Inside the last 6. Inside the last 6 questions of the official guide, you will find a disguised simple interest problem and a disguised markup question. Not quite like what we're doing here right now, but it is that kind of thing. Arshdeep, I mean, really for anyone, but this is directly in response to one of Arshdeep's comments. How do I look at this and say, this is actually compound interest? And by the way, the correct answer will be B on this one. But my question to the group, and it is in direct response to Arshdeep's concern earlier, how do I read this problem and go, compound interest? Set up my organization here. This time around, we have time frames. Again, the question is still, how do I read this and go compound interest just in disguise? 854, 857, 9. It increases by a factor. It increases by some multiplication, not by just an addition. It's a constant percentage increase, not a constant number increase. And again, here's where we're coming back to one of the core themes. Percentages are not numbers. If this was a colony of bacteria increases by 20, if you remove that percent sign, this is simple interest. And it's a very different set of calculations. You're adding instead of multiplying the numbers. The amount of change is much smaller. But that percentage tells me this is now a multiplication, a change in factors every single time. Now, how do I express a 20% increase? Using fraction form, because fraction will be the most convenient thing. You could do 1.2. And if we're on the data insight section where I have a calculator, by all means, go ahead, do 1.2. Generally, I recommend fractions, not decimals for pen to paper math. So what we have here is I start and I increase multiplying by 1.2 or multiplying by 12 over 10 every single time. And I end at 144,000. Now, there are a few ways you can go about this. One way is to say I have some unknown x, and then I have 12 over 10 times that x. And then I have 12 over 10 squared times that x. And you can say 12 over 10 squared times x has to equal 144,000, and you can solve it that way. Perfectly workable set of mechanics that you can do there. Or you can say I have 854, 857, and 9. I increase each time by 12 over 10. And I end at 144,000. I'll just leave it as 144 now. All of these progressions go in both directions. And so if I wanted to go in the opposite direction, what would I multiply by? What would be my factor? Instead of multiplying by 12 over 10, multiply by what? You multiply by 10 over 12. You do the inversion. If you do this either way, you end up with 100,000. Now, as for why 92,160, anybody notice that choice A kind of stands out here as being very, very different? This is your trap right here. This is what you get if you try to counteract by doing an 80% decrease, or sorry, an 80% of 144,000. If you try and do 20% decrease. Once you change your base number, once you change whether you're moving forwards in progression or moving backwards in the progression, your percentage cannot stay the same. We've got to map it out this way. All right. We're coming up on time here, and I want to make sure that we do see the last problem. So everybody, take a few moments. Give this one a try. We are getting close to the end of time here. And I know that people are still working on this. This one is designed to be quite a bit sneakier. Gianfrancesco, I'm wondering if you missed the word additional in the question. I'm curious about that. Let me start by saying one of the things built into this question is the idea that many GMAT questions are constructed so that you can benchmark a little bit. All of this information right here about this rule of 70, combined with 10% interest, all of that tells me that if nothing else, happens, this will double in 7 years. You take some original investment, you have it at 10% compound interest. This rule of 70 tells you that it's going to double in 7 years. Now that benchmark, combined with the idea that we need to know additional years, you got to catch that little trap there, tells me that C, D, and E can all be eliminated just by that benchmark. So it would double in 5 additional years if you put money in the account and did not touch it. But that is not what Rajesh does. Rajesh says, you know what? I'm not happy with just my initial investment. I'm going to put some more money in there. So the moment Rajesh puts some more money in there, it's not going to take this long to double from the original amount anymore. It would double on its own before anything else. And it is like the other language here is how many additional years will be required. So in this instance, if we want the additional years that would be required, we're actually looking for the minimum additional years, the approximate minimum of additional years. All of these choices, every single one has had more than double. But we wanted the required additional years. So we want the minimum. And so when we look at this minimum, we're now deciding between just choices A and B. And now here's where we might need to map it out a little bit. And notice that since no numbers are given, I would go and say, let's just choose an original of 1,000. Let's keep some numbers easy. And I want to know, when do I start to get past $2,000? And year 1, I increase by 10%, which means that I've got $1,100. That's year 1. Year 2, throughout that year, I've gotten another increase of 10%, which now tells me that I've got around $1,210. But this is also where Rajesh invests another X over $2. So we also add in another $500 there. So we now have approximately $1,700 in this account at the end of year 2. And now we keep stacking that interest. When we stack that interest again, we're adding another $170 to that about. So at the end of year 3, I have something around $1,870 in here. And we stack this on again. And now I'm adding another 10%. And now I can see that this, at year 4, this is where we will exceed $2,000. So we're looking for year 4, but we're looking for the additional years. And so after the X over 2 investment, we needed 2 additional years. Now, I want to highlight a few things from this problem before we close today. The first is, and this is something that I've been noticing a lot more in the data insights section of the test particularly. Watch their language, the additional years, the how many will be required, telling me that we're actually looking for the minimum number of years to more than double the original investment. All of those language cues are getting very strong play in the test, especially in the data insight section. The second thing I want you to notice is, again, go back to the idea of benchmarking. It gives you information to allow you to benchmark and say, if nothing else happens, if all else remains equal, this is when I would hit this goal. All else equal, this account is going to double in 7 years. Does all else stay equal? No. Rajesh adds in more. So we're not going to need 7 years. That with the additional years telling me that my required minimum is going to be less than 5. And then finally, as I hope you're seeing across all of the problems we did today, and this is one of the reasons why I deliberately left animations off of this deck, a lot of this is about the organization. track your problems, build the progressions, and make sure that you organize it and say, whether you do arrows, charts, whatever it may be, how are these things changing? Track my changes. And that, my friends, is the last thing I want you to leave you with for today in terms of these problems. When you have a progression problem, a sequence of changes, and it's always going to happen in interest questions, track your changes. Make sure that your organization can account for how are things changing from period to period, not just the initial and final values. All right. To wrap up here today, keep in mind, I'm here as a representative of Manhattan Prep. So want to make sure that you realize that you can get a free starter kit for GMAT, GRE, and executive assessment. The GMAT starter kit is actually particularly lovely because that GMAT starter kit comes with something called a Foundations of Math workshop, which is just a glorious, glorious thing. Thank you, Devanti. I hope that you had fun with this today. Since we are still in 2024, this is still this discount code here. This is valid through the end of this year, so valid for another 2 weeks, essentially. Not gonna lie, I would not be surprised if this stays a discount code for a long time, but just wanted you to know that technically this ends in 2 weeks. Anyway, I wanted to thank you all for being here today. I wanted to thank you all for your engagement in the chat. And yeah, real quickly, my email address is just cgentry, Chris C. Gentry at manhattanprep.com. And I'd be happy to, in terms of emails, there's a limit to how much I can do because I do have a lot of students that I'm taking care of at any one time. But I'd be definitely glad to see what questions you have. And if it's something that's appropriate to answer over email, I'd be more than happy to do that. So please shoot me something if you need. All right, everybody. Thank you very, very much. Have a wonderful day. Have a wonderful night. And perhaps I'll be seeing some of you in the future again. Thank you all.